Welcome back. In this video, we are going to learn about linear inequalities. So we already know what are equalities. So equalities are algebraic expressions related to another algebraic expression or a constant through a equal sign. Therefore, this expression ax plus b is equal to 0 is an equality in one variable, and this is an equality in two variables. Ax plus by equal to c is an equality in two variables. How do we solve these equalities? So we can add and subtract both sides of an equality by same number, and we can multiply and divide both sides of the equality by same number, and of course that number shall not be 0. Now instead of relating these expressions y equal to sign, relating these expressions y equal to sign, we use signs which are other than equal. That is, it may be greater than, it may be greater than equal to, less than equal to. Then such type of expressions are called inequalities. So this is an example of equality in one variable. This is an example of equality in two variables. So by definitions, inequalities are algebraic expressions involving less than equal to, greater than, and greater than equal to signs. How do we solve these inequalities? Again, we can add and subtract same number from both sides of the inequalities, and we can multiply and divide both sides of the equalities by same positive number. However, if we want to multiply and divide by negative number, we need to be careful. For example, we all know that 3 is less than 4. Now if we multiply this inequality by -1, so it becomes -3, and this becomes -4, and clearly -3 is greater than -4. So when we multiply or divide an equality by a negative number, the sign of the inequality reverses. For example, we have an expression, we have an equality -2x plus 10 is greater than or equal to 0, and we want to find the values of x which satisfies this inequality. We subtract both sides of the equation by -10, and we get -2x greater than or equal to -10. Then we multiply both sides by -1, and we get 2x less than equal to 10, and then we divide both sides by 2, then we get x less than equal to 5. In a number line, this can be represented by all numbers to the left of number 5. So we have just seen an example of solving an equality. Now we can be given a system of linear inequalities, and we have to find the values of the variable which satisfy both the inequalities. For example, we have an expression, an equality 3x minus 7 is less than 5 plus x, and another inequality 11 minus 5x less than equal to 1. Now we have to find all the values of x which satisfies both these inequalities. For the first inequality, we have 3x minus 7 is less than 5 plus x. We add 7 to both sides and we get 3x less than 12 plus x. Then we subtract x from both sides and we get 2x is less than 12. And then we divide both sides by 2 and we get x less than 6. In a number line, this is represented by all the numbers to the left of number 6. Similarly, for second inequality, we have 11 minus 5x is less than equal to 1. We can subtract both sides by 11 and we get minus 5x less than equal to minus 10. Then we divide both sides by minus 5 and we get x greater than equal to number 2. On a number line, this is represented by all numbers to the right of number 2. We can combine these two results and write x is such that it is greater than or equal to 2 and less than equal to 6. And on number line, it is represented by all the numbers between 2 and 6 and number 2 included. Next, we move to linear inequalities in two variables. So the inequalities ax plus by less than c or ax plus by greater than c involve two variables x and y. Therefore, there are linear inequalities in two variables. Now we have represented linear inequalities in one variable on a number line. To represent linear inequalities in two variables, we will require a 2D plane. So this is a 2D plane involving the variables x and y. This blue line is representing the line ax plus by equals to c. Depending on the values of a, b, and c, one side of the line may represent one inequality, that is, it may represent ax plus by less than c, and another side may represent the inequality ax plus by greater than c. For example, we have a line 2x plus y equals to 4. This is represented by this solid line in the 2D plane. This pink shaded region is representing the inequality 2x plus y less than 4. And how we know that it is less than 4? Well, we put x and y both as 0, and clearly we see that 0 is less than 4, and since 0 is in the pink shaded region, therefore this pink shaded region is representing the inequality 2x plus y less than 4, and this cyan region is representing the inequality 2x plus y greater than 4. We can have a system of linear inequalities in two variables and try to find a solution. So for example, we have an inequality 2x plus y less than equal to 4 and another inequality x minus 2y less than equal to 4. In the 2D plane, this pink line is representing the line 2x plus y equals to 4, and this pink shaded region is representing the inequality 2x plus y less than equal to 4. Similarly, this blue line is representing the line x minus 2y equals to 4, and this blue shaded region is representing the inequality x minus 2y less than equal to 4. This purple shaded area is common to both the inequalities. Therefore, this represents a region where the values of x and y satisfy both the inequalities. Therefore, in this region, 2x plus y is less than equal to 4 and x minus 2y less than equal to 4, and all the values of x and y which lie in this region are the solution of these system of linear inequalities taken together. Suppose that we have another inequality given by y greater than or equal to minus 3. This is represented by this orange line. This orange line represents y equal to minus 3, and this shaded region represents the inequality y greater than or equal to minus 3. Now the common shaded area is this little triangle. So this little triangle represents the set of all the possible values of x and y which satisfies all the three inequalities. Therefore, the set of all possible values of x and y in this triangle represent the solution of the system of linear inequalities represented by these three inequalities. That's all for today. In the next video, we are going to learn about permutations and combinations.